Hey everyone, it's Mr. Rosenberg. For this lesson, we're going to be talking about Chapter 7, Section 2, multiplying powers with the same base. And the objective of this section is to multiply powers that have the same base. So first, let's talk about product of powers. This is one of our laws of exponents, and this just says that when we multiply monomials that have the same base, we have to add the exponents together. So let's take a look at these two examples right here. So for this first one, we have x to the third times x to the fifth. Well, if we rewrote this with both monomials in their expanded form, this would be x times 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 x. Right? And now, if we were to multiply all these x's together, we have to see how many x's we have. Right? And remember, when we multiply monomials with the same base, we add the exponents. So all of these x's have that exponent of 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to x to the 8th. And we can do the same thing for when we have a base of an actual number, not a variable. Right? So be careful when you do this. When we multiply bases that have, or two monomials with the same base, we don't multiply the bases together. Right? So here this is 2 squared times 2 to the 4th. So this is the same thing as 2 times 2 times 2 times 2 times 2 times 2. And here we have to count how many 2's we have. We have 1, 2, 3, 4, 5, 6 2's. So this is equal to 2 to the 6th power. Now be careful. This is not 4 to the 6th power. That's not how we do it. We don't multiply those bases together if they're the same. If they're the same, we just add the exponents. And here's that rule of exponents for products of powers. It just says for all positive integers m and n, a to the m times a to the n is equal to a to the m plus n. So you can see again, they're just adding these exponents together. Now let's go over a couple examples. So first we have x to the third times x to the fifth. Remember, multiplying monomials with the same base. So we're just going to add these exponents together. This is x to the 3 plus 5. That's equal to x to the 8th. Same example we had in the last one. Now let's take a look at this one. Now we have fractions as our exponents. So this is b to the 1/3 times b to the 1/3. Bases are the same. Both of the bases here are b. So we add the exponents. This is b to the 1/3 plus 1/3, and that gives us b to the power of 2/3. Yes, you can have fractions as exponents. Now let's take a look at two more examples. So here we have 3n squared times 4n to the 4th. Here our base is n for both terms. 3 and 4, those are our coefficients. So what we can do, we can rewrite this as 3 times 4 times n squared times n to the 4th. And now we can multiply each set of parentheses, right? So this is going to be equal to 12, and then n squared times n to the 4th. We add those exponents together, so that gives us n to the 6th, and our answer here is 12n to the 6th power. Let's take a look at a similar example. We have negative 3a cubed b squared times 5ab to the 4th. For this, we're going to do it very similarly. We're going to put our coefficients together. So we'll have negative 3 times 5 in one set of parentheses. In another set of parentheses, we'll do our base of a. So a to the 3rd power times a. And then in our last one, we'll do our base of b. So b squared times b to the fourth. And now we just have to simplify each set of parentheses. So we do that, and this gives us negative 15 a cubed plus, or times a, that's a to the 3 plus 1, which gives us a to the fourth, and then b squared times b to the fourth, that gives us b to the sixth power.